All right, it looks like all systems are go here. We're recording. We also want to welcome our live audience to this Io-Tahoe Tuesday webinar, Operationalized AI and Machine Learning Challenges and Possible Solutions. My name is Andrew Brust. I will tell you a little bit more about myself in a minute, but first I want to introduce our very special guest, Ciprian Jichici. Ciprian is an ideal guest and spokesperson for this particular topic because, like many of us, he comes from years and years of straight-on application development. He's also very involved, deeply involved in data science and machine learning, including pursuing a PhD in that field, and he runs his own consulting firm. So the production concerns of putting regular software development and data science development together are very much on his mind right now. And hopefully, Ciprian, I haven't stepped on all your punchlines there, but maybe you can give us a little bit more background about yourself, and then I'll chime in with my own stuff, and we'll get on with the discussion.
Hello, Andrew, and hello to everybody listening to us. Thank you very much for the kind introduction, and also thank you for the invitation. The topic of today's discussion is very close to my heart, probably also because I've seen both sides of the fence. I've started about 20 years ago with what we called back then data mining, and it was purely a theoretical mathematical field with very, very little practical application. And throughout these 20 years, I've seen the field moving towards an area where today we are struggling to get business value out of it. So I think it's this unique perspective of being involved in both the theoretical and mathematical aspects of machine learning, as well in trying to produce business applications and business results that makes it very, very interesting for me.
Yeah, and my own background involves being a developer, once upon a time, and also once upon a time being a consultant and running my own consulting firm and helping to run the slightly larger one that bought mine. And a lot of the stuff we worked on involved both straight-on custom software development as well as a lot of work in business intelligence. And it's funny you mentioned the term data mining because, yes, indeed, that was what all of this was called a while back. And we worked very hard to, integrate that into what we were doing. And we found it pretty hard back then. There's a bunch of reasons for that. The technology has advanced and so forth. But I think even then we might have touched on some of the issues that we're hitting today as well. It's more apparent today, but it's consistent with what happened back then. Anyway, that's my long ago background. I work now by advising companies that are in the data management and data analytics space on how to put the most value in their products and get the word out to the market that that's what they're up to. But I also cover big data and analytics for ZDNet as a blogger. I also cover that space as an independent analyst for GigaOM. And, my own work with databases goes really all the way back to the mid-1980s with desktop databases. Like, actually, I'm dating myself, so much so that you might want to go get me a wheelchair. But I started with DBase 2 back in the very beginning of 1985. So that's enough about us, but hopefully you understand that we have great interest in the world of AI and machine learning and a lot of grounding in straight-on enterprise software development. And kind of here's where we see things. And Ciprian, I'm going to hope that this statement isn't too radical or obnoxious for you, but we talked about the data mining back then and how theoretical it was, and it is better now. Now that we're calling it AI and machine learning and deep learning, the stuff really works. The economics of storage and of compute, the ability to to scale out, the ability to kind of have elastic infrastructure in the cloud, all of that has combined to make AI quite real. The problem is that making it manageable, making it subject to the same processes that we've now kind of disciplined ourselves in around straight-up software development, that's not there. It's lacking. What we're gonna try and do today is, rather than just making a vague statement like that, we're gonna try and bear that out with some concrete examples, and we're also gonna try and propose some solutions out there, because ultimately, I don't know. Would you consider yourself an optimist around this stuff ultimately?
Yeah, I would consider myself a moderate optimist. 2018 marks exactly 20 years from my first attendance at was back then a data mining conference, and I remember distinctly that one of the hottest topics of the conference was how everything that was discussed there is so theoretical and so difficult to transform into something tangible. And here we are 20 years later, and as you mentioned, with the exceptional advancement in compute power and storage, and also in the theory and the mathematical models, we really do have working machine learning. And I think that the big challenge for today's data scientists, and not only, and we will touch on that later a little bit, is how to transform that working models, that working theory, into something that has business value for organizations of different sizes, for users of different profiles, and so forth. And I think that as we speak today, this is still a huge challenge, and this is why I'm moderately optimistic, because I know that is a lot of work that still has to be done in order to get to a point where all of this gets to be productive, all of this gets to be really mainstream in terms of business operations.
And I guess a big thing when I talk about topics like this is there's usually something that gets me a little angry. And what gets me angry today is the marketers who are portraying the technology as being 100% completely manageable, and that all these points of friction that we're going to talk about, it's as if they don't exist. And ultimately, I think that does the discipline a disservice, because we need to make it better for enterprises to be able to put it to work and to have success in doing so. So let's try and drill down a little bit and get more specific. I don't think a complaint has much credibility without that specificity. And we've got some points up here on the slides, and we kind of know the skill set issue already. We know that the data scientist position is highly paid and highly rarefied, and that there's a chronic shortage of people with the skills. But I think once you go beyond that, because a lot of that is kind of headline hype, and you get into the practicalities of it, the way folks in that world work, the tools that they use, sure, the languages are different, but the tools that they use and the practices and what they do from hour to hour and the culture around what they do, that differs pretty widely too, and that results in differences in the way their code is managed. Could you give us a little more color on that? Because even that is probably still a little vague. Maybe you could help us make it more concrete.
Yes, of course. I've had a privilege of working for the past 5 years into some quite large projects that have a distinct and consistent component of data science. And the first thing that I've learned, mostly from those projects where I have the position of a project manager, is there is a fundamental culture difference between what I call the classic developer on one side and the data scientist on the other side. And when I talk about a classic developer, I would also split that into two major categories, because you have the DBAs, or the folks who develop data-related code, but what I call classical data-related code, and the code developers, the one that writes the APIs and the portals and everything else. And there is a distinct difference of culture between the API developers and the portal and the code developers in general. But where I see it even more pronounced is between the DBA style or the DBA role and the data scientist, because they're not only different in culture and approaches, but sometimes you also have issues between these kinds of roles that derive from their different approaches to data, their different approaches to entropy, their different approaches to stability, and so forth. And this fundamental difference of culture also drives, of course, different practices and inevitably different development environments. And if you think about the classical project where you were developing, let's say, a portal or an API or a standalone application, what you typically do when it comes to the development environment, you do a decision up front. Well, it turns out that in many cases with the data science teams, even if you do a decision up front or you impose something at the beginning of the project, things will rapidly change. And sometimes it's because the data scientists found out that there is something new that suits better the purposes they're trying or the objective they're trying to achieve, or simply because the initial decision was so complex that it proved to be wrong, and so forth. So I've seen it like in practice, in the real world, these differences, and they are not to be minimalized. They are, of course, technical ones, but I believe the most significant ones and the ones that generate the most problems are the differences in culture, and because of differences in culture, in differences in practices and in approaches.
All right, let's see if we can explore that a little further. And again, I think we're both optimistic that there are ways to make the cultures merge. I think maybe the extremity of the issue comes from the fact that the cultures simply evolve separately. And now that they're being unified, now is a great time to create some commonality between the two. That couldn't really happen before. You're working on a project right now, and without, obviously disclosing anything about it that's confidential, we can at least give a thumbnail sketch of, some of what's happening in the structure of the project and some of the challenges you're encountering. So, as we discussed it before this webinar, Ciprian, you mentioned that, and you're based in Romania. You're working with a corporation there, quite sizable for that market, over €1 billion in revenue, and what you're working on is customer behavior analysis. And feel free to tell us a little bit more about what that really means. But before you do that, I'll just kind of sketch out the fact that your development team overall breaks down into 4 sub-teams, and there's one for data science. Certainly that shouldn't be a surprise given the whole context of our discussion here. You've also got a data platform team, and maybe you'll tell us a little bit about what they do. I doubt they're just straight DBAs or data access programmers. Then there's a team working on an API, and then you've got front-end folks as well. So maybe you can tell us a little bit more about the role of each, and also what you mean by behavior analysis.
Yeah, I think the first interesting thing here is how this project actually came to life. And the project was started after a number, if I recall correctly, 3 failed attempts to employ different kinds of external consultants for doing customer segmentation and customer behavior analysis. And after these failed attempts, what this customer decided was, we want somebody who can deliver us the business features, not the technical features, not the data science features. So basically, the most important thing about this project is that its end customer is the business person, and actually, in our case, is the business person from the marketing department. Throughout this project, what we aim to do is to provide a platform where people from the marketing department can define and analyze in real time, and this is an important thing that we will talk a little bit later about, in real time, different customer segments, and then based on those segments, analyze the behavior of those segments. Think about this company. It has around 100,000 active products and tens of millions of customers, and analyzing the behavior of each individual customer or of each segment or micro segment of customers is something that is quite difficult to do for a business person if you don't have the right tools. So that was basically...
Is the behavior, does that correspond to online behavior and clickstream analysis, or it maybe, you know, at their, if they have physical stores, the behavior in terms of how they browse the aisle? Go ahead.
These folks are in retail. They have physical stores. They have in Central and Eastern Europe, they have thousands of them, and they also have an online presence. So basically, by behavior, we understand a combination of what we call the transactional behavior resulting from in-person transactions in the stores, as well as the online behavior. And the aim is to unify these two models and then to be able to answer some interesting questions like the next best product recommendation, or the customer life cycle, which is basically defined by the stages a customer goes through from being a potential prospect and ending up to be a consistent customer, or in the worst case, being a churn customer. So this is basically the reason that this project actually existed. And when we started working, it was pretty clear that we will need to build some kind of user experience for these customers who are persons from marketing departments. And that's why we have this team that actually develops a front-end portal. But being a large company, you have a lot of systems, you have a lot of platforms working in. So basically, we need to integrate everything in one place. And that's why we have these other two teams. The one is the API team that basically creates an API that it's on one side consumed by the front-end portal, which is used by the business people, but on the other side, it's also consumed by other business processes and other platforms throughout the company. And the idea here is to have a single point of interaction when it comes to customer segmentation and analysis within the company. And then we have this data platform team that does a lot of heavy lifting in terms of integrating these data sources that are available throughout the entire company, and also they are available outside of the company, because some of the models that we are dealing with need some external data as well, and they do a lot of heavy lifting in terms of prepping the data and make it actually available to the data science team on one hand, and on the other hand, they have this quite difficult task of taking data produced by the data science team and feeding it back into the regular business processes of the organization. And finally, of course, the data science team is the star team of the project. These are the folks who basically need to create the models, they need to train the models, and what's even more difficult, they need to deliver. They need to create that magic that is expected by the business of predictive models, of clusters, regression models, deep neural nets, and so forth. So that would be a very high level description of how we broke down the team structure for this and how this works. And from talking to many of my colleagues, didn't mention that in the beginning, I'm part of this program called the Microsoft Regional Directors Program, where I have the opportunity of interacting with a lot of other regional directors from all over the world. And from talking to them and discussing with them, it turns out that this is a pretty straightforward and pretty common these days structuring of projects. Even if you don't see all four of them, but in many cases you will see a subset of these teams. You will see projects where you have a data science team, a data platform team, and there might be API or portal guys and so forth. So the challenges that we are facing here are challenges that are encountered by many other teams all over the world today.
So I think in terms of practical value, just laying this out is real helpful for our attendees to kind of know that there's an emerging consensus around structuring teams this way for AI projects. I think that's worth the price of admission alone. What I'll also say, my own personal observation here, and not one that I had before, is that the guys or the folks on the API team, they're kind of like the peacemakers, aren't they? I mean, they're right at the joint between everybody else, especially in terms of getting the portal to talk to the back end data models and make it so that doing scoring or running predictions is doable. There must be a lot of pressure on each one of these teams. Nobody has an easy job.
It is, Andrew. Yeah, it is, and that clear disruption in terms of culture is basically mitigated by these two teams that I don't think it's by chance that even in your slide are at the middle. The API and the data platform team, besides many other things, they have this difficult task of mitigating the cultural and all the things that derive from these difference between the world of data science and the world of classical application development.
So, well, I would say we don't envy them, but maybe we do. I mean, this must be very gratifying, once it's done at least, for their career to have gone through this. This is pretty much a space for pioneers right now. In terms of the interface between, and really we're talking about the interface between the data science team and the other three, there were some difficulties that came up, and I'm just going to build out this slide rather than kind of keep everyone in suspense. But now we're getting down to real specifics, and these are the mechanics and these are the tactics of doing software development. Versioning is a real thing. We're used to having to do that when we're building kind of conventional applications, but it's also important to do it in the data science world as well, especially because it's so iterative and experimental. Meanwhile, the tooling and the ethic and the practices around doing it aren't so good. I mean, it seems like a lot of data scientists I talk to, basically what they say is they get into a jam session on their machine. They keep trying new algorithms, new, slightly re-engineered data sets until they get it just right. But they're not tracking all those steps. That's just not part of their discipline yet. And maybe I'll let you kind of speak through some of the other things, especially if you could talk about aligning infrastructures and what that means.
Yeah. there are some unique challenges here, and as you mentioned, this is both extremely difficult, but it's also very, very gratifying, because in these type of projects, basically what you do, you're breaking ground, so you are tackling issues that are new and sometimes unexpected, and that makes this work really, really interesting. About the versioning stuff, the interesting part here is the fact that for many, many, many years, we used to focus a lot on versioning code and not so much on versioning data. Turns out that with data science, versioning code is equally important as versioning data. In some cases, I might say that even versioning the data used to train the models is even more important than properly versioning the code. And the reason for that is the result, the final result of a machine learning process, which is in terms of development, of course, which is the trained model, is highly dependent on the data inputs. And if you iterate through this process many, many times, then at some point it becomes very, very difficult to remember or to find what was the actual data that has been fed to a specific machine learning model in the training process and then in the testing process. And that poses some unique challenges. And of course, directly from this, you have the source control and build issues, simply because the environments are really, really, really different. And this gets into the third interesting challenge, which is the challenge of infrastructures. And we go back again to the difference of cultures. For instance, in this particular project, the API team is a team that builds on open source. It builds on ASP.NET Core, and they run their services on Windows environments. Actually, they run on Microsoft Azure, but they choose the Windows Server types of environments and all their specifics. While the data science team is a team that comes from the Linux world. They of course do a lot of Python. They do some R. They do some Spark, and then also sometimes they rely on some Databricks stuff. So having an infrastructure specification for the API and the portal teams and for the data science team are two very, very, very different processes. And even more than that, for the classical development teams, and I'm referring here to the API and the portal teams, once they decide on a specific infrastructure, and I mean specific in terms of going down to settings and everything that is related to an infrastructure, not only the choice of an operating system, that decision pretty much does not change. I don't think they've ever changed it since the beginning of the project, which was about 18 months ago. Well, with the data science team, that's totally different. We have frequent changes in terms of infrastructure requirement. And I want to make that very, very, very clear. That's not because the data science team doesn't care about the implication, or the data science team doesn't have the knowledge and will to create a smooth process from this. Sometimes it's simply because there's a new library in town, there's a new approach in town, and they need to try that, they need to test it, simply because they are under enormous pressure of delivering results. And for them, results are the level of accuracy of their model, the recalls of their model, the precisions of their models, and so forth. And basically, this boils down to the different types of pressure that is applied to these teams. And finally, the fourth one is, again, a pretty interesting one, which sort of derives from the infrastructure mismatch between these teams. It's at some point, different pieces of code will have to communicate with each other. In our cases, it's the API that needs to call straight into data science code, because as I mentioned at the beginning, one of the goals for this solution is to provide real-time or near real-time operation for the business person. And think about a very simple example of a sample process, right? A person from the marketing department has a specific budget, for instance, for an emailing campaign or for a mobile phone-based campaign, and then uses a lot of these interactive modeling tools that we have in the platform to create some customer segments. And once the customer segments are created, and let's suppose for the sake of simplicity, there is one segment with, let's say, 100,000 customers, then the immediate need of that business person is to learn more about those 100,000 customers, not all the customers of the company. And ideally what they need is to basically reapply, but in real time and only for 100,000 customers, most of the models that were trained for the entire population of customers. They might want to see what the specific behavior of that 100,000 customer is, or how they can be further clustered based on their behavior and so forth. And that's where we end up needing to call from the API models that need to train in real time, and they need to deliver predictions or results in that near real time. And that turns out to be a unique and very, very interesting challenge when you have a classic like API solution that needs to call into some results of a data science process, and those results are not available a priori. They need to be trained on the spot, and they need to deliver results on the spot. That's what makes this challenge unique and very interesting.
Yeah, it seems like for the data scientists that the massive pressure on them is around an immediate result and not necessarily around process or anything repeatable. And for the application folks, it's more the opposite. You know, obviously the application needs to work and they need to produce results too, but it's got to have real engineering in it that makes it reliable, that makes it repeatable, and that makes it manageable. And hopefully, eventually, we'll get the two camps to have goals and KPIs that are more in common. I'll mention also, and maybe we can get to it more towards the end of the discussion when we talk about possible solutions, but the folks at Databricks are pushing now an open source project actually called ML Flow. ML, of course, standing for machine learning. And one of the things that's built into that is the ability to do versioning on data sets. And in a pretty creative fashion, because they know that different data scientists are going to work in different environments. Some are just going to work at the command line. A lot of them are going to work in notebooks. You know, others may work in something like RStudio. And there needs to be a way so that no matter, you know, which environment they're in, as they iterate and change their data set and maybe run a suite of tests against the model, that gets logged. And there is industrial realization that this is a need, and there are some tools forthcoming, although it's still pretty early days. So we've talked about some specific challenges in your project. Maybe we can try and distill those more generally. And as you can see here, versioning gets its own slide. So one thing we need to kind of point out, and I notice, and I'm glad, that not only are we kind of pointing out issues and problems, but we're also talking about root causes, and I think we're being appropriately sympathetic and empathetic where necessary. So the data science folks have to deal with a lot of churn on the consumption side. They're using all these different frameworks. They're using all these different packages within the languages. They're combining them, and each one, especially because it's open source, everything's open source. They're getting updated on their own schedules and their own cadences. And the data scientists have to kind of, they have to navigate and orchestrate through this chaos. And so that's their world. We should be understanding that their tolerance of that probably also leads them not to, or leads them into a place where having, applying a double standard where they have to be more disciplined around versioning their own stuff, we shouldn't be terribly surprised that that's a lower priority for them. But it is the crux of the culture clash. And we said it at the bottom of the slide here. There's a typo I just noticed, but what is de rigueur for application developers is also alien, or at least strikes them as fussy for the data scientists. That there is a double standard, there are different expectations, there are different metrics for success between these two groups. And that's something we have to address, not just on your project, but probably on every single production AI project. Now that I've read everything out in a monologue, maybe you have some thoughts to add, Ciprian.
Yeah, and I will start with the last point that you made. One thing that I see, and it's not only in the projects I'm working in, but I see it a lot even in conferences and in lots of engagements that I have with both regular developers and data science developers, is, for instance, the culture of code clarity. This is something that has been pushed and is heavily rooted into the mindset of classical developers, right? Don't use cumbersome language constructs if you really don't need them. Don't use the super shorthand approaches of the language that you are developing in unless they're really, really necessary. Always think about code clarity. Now, this is quite the opposite in the camp of data science developers, where sometimes they take pride in having cumbersome and sometimes even weird language shortcuts that they use. And of course, this also plays down to the mindset that they have, and the fact they're really, really theoretical people, and they are into high complexity in almost every respect of their work. But when you bring this into a real life project, you have the problem like onboarding a new person into the team, minimizing the time a new person in the team needs to get to be proficient in the code that has already been written, and so forth and so forth. So you have these interesting things that come from this, and then it's the unavoidable situation of the high complexity of data science development environments. You have tens or even hundreds of different libraries, and they have simultaneously lots of active versions, and the dependencies between these libraries are sometimes very, very difficult to even understand, not to talk even about overcoming them. So this is the reality, and to be honest, I don't think this will change, and I don't think this is sort of the expression of some kind of sloppiness or whatever. This is an objective situation in the data science world, because there is still so much work being done as we speak in terms of implementing better models, developing better models, developing new math and new theoretical constructs for tackling some of the problems with the current models, so that I don't see this this level of entropy in the data science world significantly changing in the forthcoming years. And that's something that we will need to embrace. we'll need to be cool about it, and we will need to try to take the best out of it and incorporate it into the process of building business-oriented applications. And you were mentioning the folks from the Databricks teams, and they're actually creating the first open source and universal attempt to provide an environment that will enable you to track experiments, both in terms of code and data, but also configuration and results of those experiments, enable you to track data science projects through a reproducible packaging format for the results of those projects, and of course through models which they attempt to propose a general format for machine learning models that will support different deployment tools and different platforms and so forth. So there is a lot of work already being done in this field. People are realizing that these issues are real issues, that they need to be tackled, they need to be addressed. And I will end this intervention by saying this. I think the second point of your slide is very interesting in a sense that on one hand, the data scientist has to be really tolerant of the conditions of the generated by the entropy of their environment. But also, I would say this: I think that at some point, data scientists will have to give up a certain level of freedom in order to become more proficient, more productive, more oriented towards business goals. And I think this will be one of the trends that we will see for the next 3 to 5 years in this specific field. Of course, they will never have the luxury of living in an environment as predictable as the environments of classical development. But at some point, as I mentioned, they will need to give up some of their freedom. It is still debatable how much of that freedom they will need to give up. Honestly, I hope as little as possible, but still this will happen. And it has clear and distinct links to this issue of versioning and all the other issues that we were talking about.
Yeah, understood. And what was I going to say? I think it's also incumbent upon us to realize that, you know, the very title that they have, if you think about the word scientist, you know, it's not, the science of AI is in a great state. What's missing is kind of the prioritization of commercial concerns, and that's really the difference here. Is can we kind of get a merging of the scientific / laboratory / academic pursuit along with the more mundane but super important priorities and criteria of the commercial world, and of making it so that this technology isn't just sort of working but gets adopted. That may seem like a trivial point if you're a scientist, but it's really the whole game if what you're trying to do is build industry around this. So some other issues we have kind of just summarized in a single slide here, and in many cases they're restatements of things we already said, but the data scientists are really doing iterative experimental work, and you know the ends sort of justify the means for them. They're really focused on getting the right result and doing whatever they can as quickly as possible to get there. So that's a thing. The application developers are much more focused on production values and of keeping things repeatable and reliable and so forth. Integrating the data science code and the application code. So we talked about the difficulties you had there on your project, and what we're trying to do is call that out here as a general concern as well. Boy, maybe you could talk to us about what it really takes to put everything under source control and actually do a build that brings in all the changes from all the teams. And on the aligning infrastructures, once again, we did speak to that with respect to your project, but we also want to call it out as a general thing. I think, by the way, that because of what you mentioned, that the team breakdown into the 4 units there, you're saying that's pretty common across projects, so not terribly surprising that the integration and the infrastructure alignment that friction points that you've hit, we're saying are general issues here as well. But boy, if you could tell us more about how you handle the nuts and bolts of source control and build management, and any other thoughts you have on this slide, that would be great.
Yeah, that's probably the one topic that we haven't touched so far with in more detail, and it's really an interesting one because I've already mentioned the difficulties of doing versioning and from that also source control with data science related code, but it gets even more tricky when you start thinking about the entire type of life cycle. When you want to do, like, for instance, continuous integration, or when you want to do some approaches like running an overnight build of everything you have and then automatically deploying that into some test environments and running tests on those environments, getting the results, and then just doing this over and over again. And it also has to do with one thing that I've mentioned, and this is something that I believe we will see more and more. We've started with data science in a very static context, in a sense that you typically, even a few years ago, you had a data science team that was like working for weeks or sometimes months on some data set or data sets, producing a model, a trained model, and that model then was basically used to sometimes generate some new data that was sort of fed back into the original data sources or maybe other data sources that were related to it. What happens these days is we see more and more pressure on the data science teams to also do real-time or near real-time stuff, like functionality that enables you on a click of a button to eventually train a model and then use that model to do some scoring or do some predictions or whatever. And that has a direct impact on these challenges related to source control and on the entire build processes, because all of a sudden you have to test that type of scenario where you have a business user that does something on a user experience layer and then clicks a button, and the click of that button eventually translates into the identification of a source data set that needs to be split into training and test, and then the model needs to be trained, and then the model is used to do some scoring and so forth. And automating that becomes quite difficult, and I think is one of the core challenges in today's landscape of implementing and designing these mixed types of applications where you have classic approach as well as data science related approach.
And one thing you just made me think of, and notice I forwarded the slide so that we can kind of quickly talk about the tension between simplicity and manageability. But one thing you just made me think of as you described that is that what we're almost doing is taking analytics, which we're used to doing kind of offline as a separate process from, the application's own operation. And we're actually bringing that in as a piece of the application itself. So that's almost a contradiction, right? That we're taking something peripheral and making it central. And gosh, maybe that's one reason this is so hard, and maybe that's also one reason why what we have on the slide here, is what we say it is, right? Going for simplicity, going for something that works so that you can get a result and move on, like that's understandable, especially if what you're trying to do is kind of offline and peripheral. But if you're going to make it part of the operational side of things itself, part of the just the central activity and day-to-day kind of interactions in an application, then different criteria come into play, and it's almost a philosophical question here of, which one do you want? And how do you take something that's normally peripheral and bring it in the middle? Again, I'm at least optimistic, but these are hard questions. No wonder the answers are emerging so slowly, because these are much harder philosophical questions than we've had in software before, I would say. If it's okay with you, I'm going to forward, since we only have about 5 minutes left, to talk about some possible solutions here. And so we have some of them up here. I don't want to kind of read the slide, but I'll just give some highlights. So you had a suggestion that notebooks, Jupyter notebooks, since those are the most common, perhaps there's some correlation between how notebooks are used and how things are versioned. In terms of tooling, we talked about ML Flow. And what we didn't talk about, but what we probably ought to mention, is that the different cloud providers have experimentation services as well. Microsoft has one that's in preview, which is the Azure Machine Learning Experimentation Service. If you go to the Amazon world, there's Amazon Machine Learning, and there's also SageMaker. So maybe those are some ideas on the manageability side. If you go all the way to the right of the slide, maybe there's some stuff that can actually make its way right into the IDEs, the integrated development environments that mainstream developers are using. And maybe there's a way to automate things so that they can actually do some of the things that we require data scientists to do today. Maybe some of that can be automated by tooling and machines and doesn't have to be a manual human process each time. And in terms of all the churn and all the flux in the core data science platform, this was my proposal, that maybe we can have kind of distributions of those things that get their own version number, just like we have for Hadoop distributions today, where all the internal pieces are of a specific version and are tested for compatibility. And then instead of folks downstream of those distributions updating the subcomponents, maybe what they do is they update the major distribution, and when they do that, they get newer versions of the things within them. So I just said an awful lot. Maybe I could get your reaction.
Yeah, just a quick one on manageability. I think what the one thing that is really needed today is a way to increase the level of abstraction at which we are treating data science code, right? So simply calling into some data science code per se, even if it's Python or R or Scala or whatever, it's clear for me that it doesn't make the cut. So you need to have a higher level of abstraction for that. And one approach that I like is, and I find it very interesting, is the notebook paradigm. For instance, if you're on Databricks, you can, as of today, you can actually execute a notebook, and you can execute the notebook by simply making an API call. And the notebook itself can be as simple as 2 lines of Python code, or it can be the most complex deep learning training and scoring type of code that there is. And this is one kind. I don't say they need to be necessarily notebooks, but I think this kind of paradigm is something that we need to have.
Makes sense. What do you think of the distribution idea before I push us to the next slide?
Oh, it's inevitable. If you think about today, and let me just give you an example, right? Think about doing data science, for instance, using Python, right? You have myriads of packages, and today, if you use something like Anaconda, for example, you can design your own environments, and then you can install those packages and so forth. But when it comes to integrating this into automated DevOps processes, it's very difficult. So basically, what is needed, and I'm convinced will happen, is basically the next level or the next step here, where you can have these sort of more or less standardized types of environments that have names and versions of their own, and then you simply refer those, and they can be easily and efficiently automated into complex DevOps processes. So that's about to come any day now, and I think it's so badly needed that it's almost unavoidable that we will have that at some point in the rather near future than the distant one.
Yeah, we at least need to get people to start thinking in terms of changing things at the molecular level rather than at the atomic level. And then,
Yep.
you know, one note to kind of finish off with here is that all of this complexity that we're talking about, if you're a customer, this can be avoided, and you can make yourself the beneficiary of all the goodness, of all the upside here by using products that have AI built in, that have embedded AI. Because in that case, the models are built, the deployment is not your concern. Obviously, everything's integrated. If there's retraining involved, then that's been engineered. Basically, all the burden goes on the software vendor instead of you. And today, given all the choppiness of the data science stack and environment, this really may be the best way for customers to realize the benefits of AI. And it shouldn't be a secret that I bring this up because, in fact, Io-Tahoe takes that very approach. There's built-in machine learning, deep learning, and natural language processing involved in discovering hidden relationships between, within and between databases, and helping build out an extrapolated data catalog based on the discovery that results. And the fact that AI is in there is a great kind of boon to productivity, but it's not something that the customer even needs to be aware of. And very often with new technologies, that's the best and most hopeful way to kind of get the benefit and spread it around, is to get it embedded so that it's doing its work, but that the customer doesn't have to get their hands dirty in understanding the operation of all that. So we'll leave that mostly as a stopgap. Of course, we want to get it so that enterprises can integrate AI into their day-to-day development processes. But there are stopgap solutions that can be taken today. That brings us to the top of the hour and the end of our presentation. It's a holiday here in the United States tomorrow. We're very happy. I mean, Ciprian, you're in Europe, so that holiday isn't your concern, but it turns out you're actually on holiday this week anyway, and still very graciously joined us for this conversation and made it, you know, much more substantive than it would have been otherwise. So I just want to say thank you, and I'm sure the audience thanks you as well.
It was a real pleasure, Andrew. Thank you very much for inviting me.
Absolutely. The pleasure was mine. We'll wish everyone a good day or evening or morning, depending on where they are. This is Andrew Brust from Io-Tahoe, and I want to say thank you one more time, and that'll conclude our webinar today. Thanks.